Let's proceed further to get the dimensional formulas of some more derived quantities. And of course, force is a very important term in physics. So for force, you are aware, we require a formula here actually, to be very honest. You have not done the whole of physics till now, and there are so many formulas and laws that come into the picture. And to be very honest, to derive the dimensional formula of a derived quantity, you must know the formula that relates this f or any other quantity to the base quantities. That's important. So here, if you want to find out the dimensional formula of force, this question is asked, you have to know at least that force is given by mass into acceleration. This Newton's second law comes under Newton's laws of motion, a chapter to be discussed in near future. Now once we know that force is equal to ma, we know it means the dimensional formula of F, so you put in square bracket to mean that. This means dimension of mass multiplied by the dimensional formula of acceleration. And we have just done, short while back, we have told you, dimension of mass is of course capital M in square bracket. And dimensional formula of acceleration we have found to be L into t to the power minus 2. That was my question number 2, just a very short time back. So you can see that dimensional formula of force now coming out to be m into L into t to the power minus 2 in square bracket, and that we can write separately and highlight this. So we are writing dimensional formula of force is coming out to be m L t to the power minus 2, and that will be calling question number 3 for me and highlight it. So this is the dimensional formula of force, an important quantity in physics, and we can see that if we go for the order of dimension, I have mentioned this phrase earlier, order of dimension of force is 1 in mass because the power of m is 1 here, 1 in length because the power of L is 1 here, and minus 2 in time. Once again, I am saying the order of dimension of force is 1 in mass, 1 in length, minus 2 in time, because m, L and t they respectively represent the 3 base quantities, mass, length and time respectively. And this is of course the dimensional formula of force. So let's see how we can from here go to the unit of force. And we'll go for the SI unit actually. You can do the other units, other systems yourself. It's not a big deal, but let's go for the SI. Now the unit of mass is kg. Unit of length is meter. I have to give a hyphenation. I have told earlier in writing symbols in SI, you must put a hyphen or a dot between the component of a compound unit. So kg for mass, meter for length, and then you can give hyphenation second for time to the power minus 2. This is same thing as writing kg meter per second square. Now this quantity is known as Newton. It's better you remember this name as well. And once I say what is 1 Newton, you can quickly deduce that 1 Newton means nothing but 1 kg meter per second square thanks to this dimensional formula. So if you see some derivation of unit using the dimensional formula, and that doesn't tally with the familiar word in unit, don't be confused. It's not something different. Actually, kg meter per second square is the same quantity as Newton. They have just different names, that's all. So 1 Newton means actually 1 kg meter per second square, as equation number 3 guides us. Next, I choose work. Now this work thing, once again, if we ask what is the dimensional formula of work, then you need to know a formula which relates work to force. Work actually is defined to be the product of the magnitude of force and displacement when they're in the same direction. When a force applies on a particle and the particle moves in the direction of the force, then if the force is given by F and displacement by S both in the same direction, work is just the product of them. Hence, we can make use of this to go forward and write down the dimensional formula of work should be given by the product of the dimensional formula of F and the dimensional formula of S, S being just displacement. The first one already found above, that's equation number 3. mlt to the power minus 2 is the dimensional formula of force, and displacement being just the distance covered in a straight line. So its dimension is length, that is nothing but L. So you find the dimensional formula of work is coming out to be ml square t to the power minus 2. Let me write it again separately, and you tell me what are the orders of dimension of work. You keep thinking, I'm coming here. We are finding dimensional formula of work is ml square t to the power minus 2. I shall highlight as before, and you can already see that the work's dimensional formula is this, and its orders of dimension are 1 in mass, 2 in length, and minus 2 in time, because they are the powers of m, l, and t respectively. So looking at equation number 4, that is the dimensional formula of work, we can once again deduce the unit of work in any system, say SI. So if we are told to find the unit of work in SI, we just remember the unit of mass is kg, so we write that. L square, which means unit becomes meter square, and t to the power minus 2, that is hyphenation second to the power minus 2. This is same thing as kg meter square per second square. Now this quantity might appear to be something somewhat unusual, because the familiar unit of work in SI is called joule, which you have heard of, joule, capital J, named after James Prescott Joule. Now let me tell you, 1 joule is nothing but 1 kg meter square per second square, which we can say confidently if we look at equation number 4.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one, covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.